Imagine you have two dimensions. Dimension 1 is feature 1, dimension 2 is feature 2, and you have two clusters of data points, red ones on the right and blue ones on the left. You agree that we need only dimension 1 or feature 1 to be able to separate these two clusters. So we can get rid of dimension 2 or feature 2 and reduce the dimensionality of data from 2 to 1 regarding our goal for separating these two clusters. The second important point is reducing time and memory in computation. When you work with bigger data frames, when you have more number of columns, the storage that you're going to use will be bigger, and also the computational time, the computational cost in your analysis will be huge. So we want to somehow use dimensionality reduction to have informative features, but smaller data frame. And the third benefit of dimensionality reduction, which was actually the reason behind some of the methodologies like TSNE, is visualization. Imagine you have very high dimensional data, but you want to see if there is any kind of grouping. So this webinar will have two parts. The first part will be just more kind of introduction and why we care about dimensionality reduction, what are the approaches that we are going to talk about. And the second part will be a Colab notebook, or just you can open it as a Jupyter notebook I prepared for this webinar. And we're going to work on Python to see how we can implement those methodologies in Python for a specific data set. Scikit-learn, we are importing the composition module, and PCA is a class in the composition module. So this part is not something maybe very important for the dimensionality reduction. I'm just building the data frame that we can see the dimensions here, the shape here, with the points that I generated here. So we have these points. I'm just generating a data frame using the two features. And now we want to use this data frame in our PCA analysis. We only need two components because we just want to visualize it. We don't have any other goal for this example. And using a scatter from PLT, PLT was the abbreviation for matplotlib.pyplot. We can see that the first component is almost a diagonal line. It's something like this in the original data. And the second dimension, similar to the example I had in the presentation, is somehow perpendicular to the first principal component or first dimension. So it agrees what we described. Sorry, this A should be capital. So we understood how PCA works on some synthetic data. Now we want to see how we can use it to separate maybe the digit image data that we have. So again, to review from scikit-learn, we are importing the composition module, and in the decomposition module, we have PCA